All right, so I'm going to go through how to complete the Stardust assignment. The first thing you need to do is we're coloring in this periodic table. The main point of the whole assignment is to realize that we are to understand that we are made out of stardust and what that means, and that everything is made out of stardust. First thing we're going to do is color in the periodic table here. Now you can use whatever system software you want to do to color in this picture. The way I'm going to do it is using this free online thing, so editor. So I'm going to go down here and double click on that to open it up. So here's just a free online editor. Don't give them any of your information or anything like that. All we're using is a quick editor, okay? I'm gonna click on the picture. I'm gonna hit Control C to copy it, or right click and copy it. I'm gonna go back over here and I'm gonna click on paste. Now it's gonna be big and in the way, so I'm going to shrink it down by pulling on a yellow thing until it fits inside this white box. All right, and then I'm gonna hit apply. So now there's this picture that I'm gonna color in, okay? I'm going to use the draw tool over here to do it. All right, so we're talking about how all the atoms are made in the universe, okay? Now you'll notice the first thing here, I'm just gonna pick up, let's just do a purple pencil because that's what it gives me first. So cooling of the Big Bang, oops, and I'm just gonna, sorry, wow, it's not easy to use. All right, I'll go back to the drawing tool. Okay, and just draw an X here. Okay, so it says cooling of the Big Bang energy. And then that was just hydrogen. So I'm going to circle hydrogen over here, saying that that one was made during the Big Bang. So at the very beginning of space and time, all the energy and matter of the universe was in a single infinitesimally small spot. Why and how it got there is a religious question at this point, more than science. And suddenly all that energy expanded very, very quickly. We call it the Big Bang, even though it wasn't really an explosion. It was a huge expansion really quickly. As all that energy expanded and started to cool down, it started to form into protons, neutrons, electrons, well, quarks, and all that stuff. And then eventually those turned into hydrogen atoms when they combined together. It's obviously much more complicated than that, but simplified version, all this energy kind of coagulates into hydrogen atoms. At this point, hydrogen atoms is just one proton, maybe a neutron, and electron, right? So very simplest of atoms. Everything in the whole universe is just hydrogen and energy and other less important things for our purposes right now. But in terms of atoms, just hydrogen. That means everything, all the hydrogen that was made during that time at the very beginning of the Big Bang. Now, how do we get from hydrogen to what is this, unobtainium or whatever it's called now? I'm sure they have a name for it now, but basically all the other elements, all the other atoms. Well, what happens is what we were talking about last week with stellar evolution. So basically, as all that hydrogen gas in the universe comes together, it starts to, through gravitational attraction, it starts to coalesce together, and eventually a whole bunch of it coalesces strongly enough due to gravity that it turns into a small star or a large star or some sort of star, right? That basically is hydrogen that coagulates together through gravity, and it creates so much pressure on the inside that all of a sudden this hydrogen starts to fuse together. It's so filled with pressure that the hydrogen atoms fuse together, as we talked about 2 weeks ago in fusion. And that two hydrogen atoms come together and turn into a helium atom. And now we start to form helium by fusing those hydrogens together. This happens in the center of stars. So you can see here, oops, sorry, back over here. I'm going to pick a different color here. Let me just pick like a light blue, or let's just do green. All right, green. And then the next one says nuclear fusion by medium stars. Okay, sorry, I kind of drove over it. We're just going to have to ignore that for now. So this is for the small and medium stars like our sun that can fuse together hydrogen into helium. So we've created now helium in the inside of a star. Now those helium atoms start combining together with hydrogen and other helium and turns into lithium. And then those fuse together and turn into beryllium. And it's getting hotter and hotter, more and more pressure filled. And we're getting boron. All right, and then eventually we get all the way to carbon, okay? Notice we've only really created 2, 4, 6 elements so far, and that happens in medium or small stars. At that point, there's so much energy and pressure from that energy, it expands outward rather quickly and turns into a dust cloud, a nebula it's called. So that's this planetary nebula. So as it's forming all those elements inside the red giant, turns into carbon. Eventually the pressure gets so great that it spreads out, okay, into a planetary nebula. The center becomes a white dwarf. Now we have a planetary nebula again, okay? Now that planetary nebula can now eventually reform with other stuff back into a star again, small, medium, big star. So actually what happens is star dies, turns into a nebula, and then it can reform into a star. Now what happens if it's a large star? Well, if it's a large star, I'm going to go back up here and pick blue. We can get all the way to iron. So in large stars, because there's enough gravity pulling in, not a whole lot of pressure pushing out yet, that carbon can actually turn into nitrogen. And then that nitrogen can turn into oxygen and other elements. We can get fluorine. We can get neon. Sodium. Magnesium. Aluminum. Silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, and iron. All right, so this is happening in large stars. They all get all the way to iron, so all of these other elements are now formed in massive stars, I mean much, much bigger than the sun. By the way, those massive stars start as hydrogen as well, so that's the hydrogen gas that forms together. Inside them, they can go all the way up to iron. And now at that point, notice that's all that happens inside stars. Everything else on the periodic table cannot be formed inside of stars. So where do those things come from? Where does cobalt come from? Where does zinc come from, right? All these things. Well, what happens in large stars is they get so big and so massive and so powerful that they explode outward with a huge amount of force called a supernova. Okay, it's an explosive death of a star. There's so much pressure there and so much energy, it explodes outwards into a supernova. Now, as that explosion and huge amount of energy is released outwards, they're the largest explosions that we know of in the universe. That that energy actually causes other particles like iron, all other elements like iron, to fuse together, because there's so much energy in that explosion that causes those things to fuse together. At this point, you can color your own, so maybe pick like a different color, doesn't matter. We've already done green, so maybe orange or something like that. Okay, and now we're gonna go all the way from cobalt, and you're gonna color them in all the way through. So there's a bunch of them. Notice it happens in this row, and then we go into this row, and then all the way to radium here. So if you don't know how the periodic table works, once you go from cesium to barium, it goes to this row, lanthanum, whatever, and then goes all the way to deuterium, and then it goes back to hafnium and all the way to radon, and francium, radium, and then it goes to the actinides, which is this bottom row down here. But notice it stops all the way at uranium. Okay. That means all of the other elements in the whole periodic table, basically all the way to uranium, is created through a supernova explosion of a massive star. And then, so that's what I did in orange. You can pick your own colors, by the way, it doesn't have to be orange. All right. Then finally, there's a couple more on there. Neptunium, plutonium, americium, curium, berkelium, californium, all of those. Notice they're not created by natural means. They're created only by atom smashers used by scientists on Earth. So I'm going to pick, what haven't I done? Yellow here. Yellow's kind of hard to see. That's okay. So that means Neptunium all the way through to Lawrencium, then Rutherfordium, all these others, all the way to Actinium or whatever it's called. All those are made only in atom smashers. So they're not naturally occurring in the universe at all. So kind of weird that we can create things that the universe never actually created. Plutonium, we use that in bombs. Americium is in, everybody probably has it in their smoke detectors, and so we're creating these things with atom smashers. They're not created in our naturally occurring. So kind of crazy. All these things are created through those explosions, and then a little bit by atom smashers at the end by humans. So the important things to notice here. We can mine uranium on Earth, right? Or nickel or copper. We can find iodine, right? And xenon, like radon, all this stuff, lead, right? Bismuth we use in Pepto-Bismol, okay? So all this stuff that we see on Earth, right? We can mine it, or we can find it on Earth, or we can find it in our solar system and all that stuff. You're right. Neodymium is a magnet material. So all these things we can find on Earth, but how did those elements be right? How did they become those kind of elements in the first place? Well, it had to have happened through supernova explosions. So that means all these atoms were created by previous supernova explosions, which means that our sun is not the first star in our solar system. We've had probably 3 or 4 other generations of stars that have happened before it, and they must have been bigger than the sun because we have uranium on Earth, and all that only happens through supernova, which only happens through very massive stars. So that means before the sun there were other stars in our solar system that exploded into supernova, and that's why we have uranium on Earth. That's why we have carbon, nitrogen, and oxygen, which are super important for human beings to live, right? We breathe oxygen. We're made of carbon mostly. And so all this, we're made of carbon, which occurred in stars before they exploded, right? Because they're fusing together in stars before they exploded. So that means all that stuff that we're made out of first was made inside of a star. And so that's why we say that we are stardust. Because ultimately what we're made of had to have occurred inside of a star, because before that, the Big Bang only created hydrogen, and so only the other elements are created in stars. So you should have all this colored in, by the way. I only colored the first couple rows there, but you should color in all of them. So now how you're going to paste it back in, you're going to go over here to copy image to clipboard and click copy. And now we're going to go back here to the assignment and paste it in. Oh, great, and it didn't copy everything. Let's see if I can, uh-oh, I lost it. Sorry, let me go back and see if I can get it back. Nope. All right, before I do the whole thing over again, let's see if I can figure out a way to get this back into our thing without having back into our paper without having to. Let's see. All right. Let's see if I can save the image. We're going to save it as a JPG, and then hopefully it'll save it to your computer, and that means you're going to go back over here, and you're going to, instead of copy and pasting it, you are going to insert an image, upload from computer. If you just want to take a picture of it with your phone and paste it in, that's fine as well. Or you could do that and paste it in there. It might be easier just to take a picture with your phone because it looks like that didn't even work either. All right. So for some reason it's not pasting it. So all that work I just did. So you're going to color it in like I did before, and then just take a picture of it using the snipping tool or your camera, your phone, and then just paste it into the document. All right. So that is why we are made of Stardust. So at this point, I just talked a whole bunch and I showed you everything. Here's where you need to explain yourself using a CER. So it says our star, the sun, was formed from a nebula made when our parent star exploded in a supernova. How do we know that? That's what we were just talking about before. So use that information, that data and observations, write 3 pieces of evidence, and then use your reasoning using scientific principles, and then explain what it means when we say we are Stardust. And then finally, which object in our solar system would you like to visit and why? Just kind of a fun little question you can answer. All right, if you have any questions, please email me and I will answer them. This is going to be due next week.